because our authors have no creativity at all, they are using the same equation over and over. Now, let's leave this part here because those formula weights don't change. They've kept us with the same formula. And let's see what they say now. Let's read together here. How many grams of methane is required to completely react with 96 grams of oxygen? I hope you have a very bad short-term memory right now, because we just worked this problem going the other way. So, what's our unknown this time? Russell, what's our unknown?
Grams of methane?
Yeah, unknown. Grams of methane. And notice, I labeled it as the unknown. I put grams to remind myself we want to get to grams. Okay, and then our known this time is the oxygen. So we have 96 grams of oxygen, and that is our known. Okay, now sometimes students have trouble. They get to the point, yeah, you work with two things at a time. They have a real problem if the known is on the right and the unknown is on the left. Doesn't matter. Just two things, any order at all. So here we're set up. Okay, again, it is the most popular kind, grams to grams. Okay? And we've already left these down here. We need to go to all the way to grams of methane. All right. So we know we need 3 sets of parentheses. Or 3 sets of square brackets, take a pick, however you like to distinguish. Now, in that first set of square brackets there, what shall we do? Alex, tell me what to do.
Take 96 grams and divide it by 32 grams per mole.
Okay, fantastic. And what did that do for you? What does that...
It gives you the number of moles of oxygen.
Excellent. Okay, and moles come around on the top. Fantastic. Now, why'd you do that? Because that's grams. It wasn't a gift of moles. We didn't get to just slap it in there. So we had to stop and switch it. Okay, now, this time I need a mole ratio. Charles, tell me what to write.
1 over 2.
1 over 2. It's 1 mole of methane, 2 moles of oxygen. Remember, this came around on the top. This is on the bottom. We're in good shape. Now, Bruce, I think that was a sticky point for you before. Are we okay now?
That makes sense.
Okay, because whatever you have of this, you need half as many of this. Okay, but we want to go all the way to grams here. So what are we going to do, Antonio?
I'm confused with that part.
Okay, if you stop right here, you would have moles of methane, but you need grams of methane because of this particular problem wants grams of methane. If you were back in chapter 2, you had moles of it. You want to get to grams of it. What should I stick in there?
The formula made
Of what?
methane.
Okay. 16.0 grams of methane for every 1 mole of methane. Now, notice I've separated this a little nicer than I did down here. I just had grams / moles. Then you know what's on top and what's on bottom. But here, moles of methane, cancel moles of methane. We're left with grams of methane. And if I'd really followed my own advice, I would be slapping methane on everything that pertains to methane. So I would say, units I want, I must have set it up okay. And then we're going to punch that through, and we're going to think of sig fig. Steve, what did you get?
24.0.
24.0 grams. Great. Great. Everybody